Let's get right into it. Welcome to this Efendi Agro Explainer, where we're taking a practical, no-nonsense look at why a plow is arguably the most critical tool for your farm's bottom line. We really need to look past the surface here and treat agriculture like the precise science it actually is. Too often, we treat plowing as just another routine chore, right? But the reality is, how you manage your steel in the dirt dictates everything, from your daily fuel budget all the way to your final harvest yields. So let's dive into exactly how this works.
Here's our game plan for this explainer. First, we'll talk about why plowing is way more than just turning soil. Then we'll break down the anatomy and types of plows, how to properly match your plow to your tractor, and the reality of soil mechanics and resistance. Finally, we'll dial in your efficiency and adjustments and go over how to avoid those really common plowing mistakes.
All right, Section 1, more than turning soil. We really need to dismantle a very common myth right off the bat. A plow is not just a heavy piece of metal dragging through the dirt. Think about it, a plow is a precision instrument. Every single time that blade cuts, lifts, turns, and loosens the soil, it is actively preparing the seedbed and burying crop residues. That means any miscalculation here is going to cost you fuel and yield. Consider what a moldboard plow is actually accomplishing in just a single pass. It's controlling weeds, it's improving soil aeration, and it's resetting the field's moisture exchange for the next operation. If your setup is mismatched or poorly adjusted, you're not just doing a bad job turning dirt, you're actively destroying the soil structure. You're suffocating future root development, and honestly, you're burning expensive diesel for absolutely zero return.
Now, there's a deeply ingrained habit in farming that tells us to drop the plow as low as the tractor can possibly pull it. You might think maximum depth equals maximum yield, right? Well, actually, deeper is not always better. From an engineering standpoint, plowing too deep without a specific crop requirement or an actual compaction reason just wastes diesel and risks damaging your crucial soil structure. Your depth should be dictated by the specific crop type you're planting, current moisture levels, and whether you actually have a compaction layer that needs breaking. Overworking that soil just increases erosion risk and unnecessarily accelerates wear and tear on your tractor. Moving on to Section 2, Anatomy and Plow Types. To optimize our fuel and time, we really have to understand the specific engineering of the tools we're pulling. Knowing your hardware is half the battle here. Let's look at the anatomy of a standard moldboard plow. The frame, share, moldboard, and three-point linkage all have to work together perfectly to transfer the immense forces of cutting and lifting back to the tractor. The share is your cutting edge. It slices the soil horizontally. Then, the moldboard lifts and inverts that slice. The land side acts as your stabilizer against the furrow wall, and the frog is basically the backbone holding the whole shebang together. The heavy-duty frame is there to ensure the geometry stays true under thousands of pounds of pressure. If the angle of that share or moldboard is off by just a couple of degrees, your tractor is literally fighting the earth instead of gliding through it. But keep in mind, the absolute best plow heavily depends on your specific soil type. Take the slatted or zgarly design, for example. If you're working in heavy, wet clay, a solid moldboard creates this massive suction effect. The soil sticks, the plow drags, and suddenly your wheel slip goes through the roof. By switching to a slatted design, you break that suction, which saves you massive amounts of tractor pulling power. Conversely, if you're in rocky or incredibly hard, dry soil, a disc plow might actually be your best bet because it rolls right over obstacles instead of snagging on them. It's all about matching the specific steel to your specific soil. And what about when you encounter a severe compaction layer or a hard pan? Well, you shouldn't be using a standard plow at all. That's when you transition to a subsoiler or dip kazalner to shatter the subsoil without inverting it. These use narrow points to dive well below the normal plow zone. They lift and fracture the compacted earth, restoring drainage and oxygen flow, which is absolutely vital for deep root growth. If you try to fix a deep compaction problem with a standard moldboard plow, you're just going to create a new hard pan lower down and likely burn out your transmission trying to pull it. Let's roll into Section 3, matching your plow to your tractor. Because having the perfect plow means absolutely nothing if your tractor isn't correctly matched to pull it. When you're sizing your equipment, you've got to remember that raw engine horsepower isn't what pulls the plow through tough soil. You always have to account for power losses, traction, and the actual power making it to the ground. A super common mistake is buying a plow that requires 100 horsepower based on your tractor's engine rating, only to get out in the field and find out you actually only have about 80 to 85 usable horsepower after transmission and traction losses. Sizing your plow based on available drawbar or PTO horsepower is literally the only way to ensure you aren't constantly lugging the engine, which leads to poor work quality and definitely shortens your machine's lifespan.
Through the three-point linkage, the resistance of the soil actually transfers weight right onto the tractor's rear tires. This means correct ballast and tire grip are just as critical as engine size to prevent excessive, fuel-wasting wheel slip. Plowing is a dynamic system. As the soil resists the plow, the top link pushes forward against the tractor, dynamically transferring weight down onto that rear axle. If you have the wrong plow size or your top link isn't properly adjusted, you completely lose this weight transfer. Your tires will spin, your fuel gauge will tank, and your forward speed will slow to a crawl. Proper front and rear ballast, along with correct tire pressure, are completely non-negotiable here. Which brings us to Section 4, Soil Mechanics and Resistance. This is the actual mechanics of the soil itself, acting as the ultimate judge of your tractor's efficiency. You really can't cheat physics. Just think about the specific resistance of the soil and how it jumps drastically based on its composition. Clay soil acts like literal glue against your steel. If you're plowing light, sandy soil, you're dealing with a specific resistance of around 220 to 350 newtons per square decimeter. But the moment you cross into heavy, wet clay, that resistance can triple or even quadruple. This means the exact same plow set at the exact same depth is going to require exponentially more tractor power just because the soil texture changed. Hitting a maximum of 1,200 newtons per square decimeter in very heavy clay is no joke. You can clearly see why taking a plow size for sandy loam into a heavy clay field will instantly overload your tractor and destroy your fuel economy. This is exactly why we never make absolute claims about fuel consumption or yield increases. A setup that burns 15 liters per hectare in loam might easily burn 30 liters in heavy clay. If you don't adjust your working width, like say by dropping a furrow from your plow when you move into heavy soils, you will induce massive wheel slip, glaze the soil, and severely compact that sublayer. All right, Section 5, Efficiency, Fuel, and Adjustments. So, how do we mitigate all these forces and actually dial in our efficiency out in the field? It all comes down to meticulous calibration. Getting your setup right requires strict adherence to these adjustment steps. A perfectly leveled plow with the correct top link alignment minimizes soil resistance and ensures even crop emergence. Transverse leveling, or emission parallelikaiare, making sure the plow frame is perfectly parallel to the ground while the right tires are in the furrow, is absolutely critical. If your plow leans, your depth is uneven. That means some seeds get planted in deep, wet soil and others in shallow, dry soil. Next, controlling your working depth and aligning that top link ensures your draft line is straight. When you have a perfectly balanced tractor-plow combo, you can run in a higher gear at lower RPMs. And that right there is the ultimate secret to fuel efficiency. Now, we cannot say one method is absolutely better than the other. Your choice between traditional plowing and reduced tillage really has to be an objective calculation based on your specific field moisture, residue levels, and long-term farm goals. Traditional moldboard plowing is unbeatable if you need a clean slate, especially if you're fighting heavy weed pressure or massive amounts of corn stover. But if preserving soil organic matter and conserving spring moisture are your primary agronomic goals, a reduced tillage approach using chisels or cultivators might be vastly superior. As an engineer, you have to look at the field conditions first and pick the tools second. Let's wrap things up with Section 6, Avoiding Common Plowing Mistakes. Because even with the best equipment and calculations, human error in the field can still ruin your operational efficiency. These are the true efficiency killers we see on farms all the time. Working in wet soil destroys aeration and causes severe compaction, while excessive wheel slip acts like a hidden tax on your daily fuel budget and machine lifespan. Plowing wet soil is perhaps the most destructive habit out there. It smears the furrow bottom, creating a waterproof seal that roots simply cannot penetrate. And using the exact same tillage depth and method year after year, that practically guarantees the formation of a plow pan. You've got to rotate your tillage practices just like you rotate your crops. Also, remember that utilizing optional engineering solutions like skimmers can drastically improve residue management, and it doesn't require you to plow deeper or overwork the soil. A skimmer, or ånggevdejik, sits right ahead of the main moldboard. It slices off just the very top layer of soil, where all the weed seeds and tough residues live, and throws it into the bottom of the previous furrow. Then, the main moldboard covers it with clean soil. This gives you phenomenal weed control and residue breakdown, saving you significant fuel and wear. So, as we close out this engineering analysis, I want you to think about your own operation. Take a look at your fields, apply these principles, and ask yourself this final question. What is the biggest mistake farmers make when choosing or using a plow? Wrong size, wrong depth, wet soil, too much wheel slip, or poor adjustment? Think about it.
And let's keep optimizing our operations for the best possible yield.